As we move further into chapter 2, this kind of sets us up. What do you actually need to know to write formulas and names? We have the names here, and if I look at sodium chloride, not too hard to write NaCl. If I look at calcium chloride, notice it is not CaCl, but CaCl2. So what this section is going to start to teach you is the nomenclature so that you can use it to do names. Things like, if I look at these irons, I have iron oxide, which is FeO, and I have iron 3 oxide, which is Fe2O3. We can't just call them iron oxide. We have to give them Roman numerals so we know the formula and what material we're thinking of. When we get down here to the potassium sulfite and potassium bisulfite, well, you know, one really does have to sit down and think about what are those formulas. So, a little bit of silliness. This is our periodic table at our family at the holiday time. We've been making this for over 20 years. It was when my kids were in middle school, and you know how you don't like to talk to your parents when you're in middle school. So we would bake 12 kinds of cookies, and one of them were these little gingerbread men. Being a nerdy family, we decided to make a periodic table, and it is a tradition we have continued for many years. Spouses of my children, whether they passed this test or not, decided whether we could let them into the family. All right, stop being silly. The periodic table is section 2.5. Notice there's just 2 homework problems. Please just do them and get them out of the way. What we have in the periodic table is an organization. When we get to chapter 7, we will talk about Mendeleev and what he did. But for now, we just want to say this is the periodic table. I'm going to first mention the groups. There is group 1A and 2A, as well as the halogens. And they're the ones to focus on for now. Group 1 will have oxidation states of +1. Group 2 will have oxidations of +2, and those are the only ones they can have. The halogens, their primary is a -1. Now, you look at what I wrote here on the right. Metals are formed on the left-hand side, and they're kind of that ugly tan. Non-metals are on the right-hand side, and they include hydrogen, and they're kind of the light green. And the metalloids, they are the step chair, and they are purple. Now, we are going to provide you always with a periodic table on every single test and exam. So what you want to do is train yourself to look at this table and automatically remember what it is that things stand for. So I have another little page about that because chapter 7 goes into great detail with ionization energy, electron affinity, yada, yada, yada. But for now, these are the properties that you should grasp that really a practicing scientist would know. When I look at the metals, they are all solids except mercury. And you've noticed we use S in parentheses for solid and L for liquid, and mercury is a liquid. They tend to have a luster. They're malleable and ductile. Think about a wire. That is usually made of a metal. And if you think of a wire, it is often a good conductor of both heat and electricity. As a group, metals tend to form cations, and we tend to write it as M for metal, N plus as a superscript, denoting that there is an oxidation state. And metals, they are going to form ionic compounds. I said sodium chloride, calcium chloride. The sodium and calcium were the metals, and the chloride was the nonmetal ion. Again, that's what we're teaching you here. If you don't know this, this is not time to panic, okay? On the other hand, we have the nonmetals. And all of them, well, they're not as easy to characterize. They tend to be gases or solids. Bromine is a liquid, iodine is a solid. Again, don't worry about that. They have a variety of colors and appearances. The solids tend to be brittle, and they, instead of being conductors, they are definitely insulators. These nonmetals, they tend to form anions. That's where we got our Cl going to the Cl minus. But they also tend to form molecular compounds, things like CO and CO2. Notice they are covalently bonded to other metals. And again, we're going to teach covalent bonding in chapters 8 and 9. So this is just a characteristic that once you get to the end of this course, you'll say, I don't know why I couldn't understand this. I shouldn't put it that way. The third group are those metalloids. And metalloids are all solids. Their properties fall between metals and nonmetals. Many have more than one structure. Some are metallic, some are non-metallic, some are semiconductors. So we all cannot live with our devices. And our devices are based on silicon, and silicon is a metalloid. The other thing, sometimes they like to ask on an exam is hydrogen. That is considered a non-metal. We'll go deeper into that in Chapter 7. But if you can, please set in your mind what these different properties are, so if asked a word question, you breeze through it, okay? Now this also, I didn't go in the book order because to me it makes more logical sense. If I'm going to talk about metals, metals make ions, of course, but they also make ionic compounds. And again, there are the homework problems from the end of chapter. We've got some purples and some greens. So the metals, they will form cations, and cations, again, metals are formed on the left side of the table. What does a metal do? Well, let's say a metal has 11 electrons. It is going to lose an electron, and it is going to go down to form 10 electrons. Why did it do that? Well, we'll learn later that sodium is an S1, and when sodium loses an electron, it takes the electron configuration of neon, a noble gas, a full shell. But for Chapter 2, cations form from metals. Metals are on the left side, and when you form a cation, you lose an electron. On the other hand, there are anions. Anions are the nonmetals, and they are found at the right-hand side of the periodic table. Chlorine atom is an S2P5. When chlorine has its 17 electrons, it is going to add an electron and have 18 electrons. It is now going to have the electron configuration of argon. So again, lots to learn, but today is just what is a cation, something with a positive charge. We often say Mn plus. And what is an anion? We really don't use anything for that. We just kind of say an anion is a nonmetal. So if you look at the learning outcome, see if what we said here allows you to answer that question. Now, I repeated it because this is why you're taking this course. There are materials that are ionic compounds. It's where a metal and a non-metal combine, and that's really what we had on the previous chart. The neutral sodium atom, I'm going to circle it, what it's going to do is it's going to lose an electron and become a sodium ion. Where is that electron going? Well, that electron is going to the neutral chlorine atom. It is gaining an electron, and it is making a chloride ion. When this happens, what we have is the solid NaCl form. In Chapter 12, we'll go deeper. That is called a lattice, but something you can relate to. If you like French fries and you like salt on your French fries, if you could squeeze way down, I don't want to say be on drugs, but let's say you could become really, really tiny. If you looked at the sodium chloride on your French fries, it would actually have this structure. I kind of find that remarkable because most of these things we can't really relate to, but we definitely know what salts taste like on our French fries. Okay, stop being silly. Common ions. There are facts in this class. Remember, I said insight is what I'm going for. Facts are, there are the cations found on the left side of the table. And think about your human body. It needs potassium, magnesium, and calcium, and sodium. All of these go in our bloodstream. They go through cells. There's ion channels. You're going to learn about things like that in your upper level courses, but we want you to understand and have insight as to where these things sit on the periodic table. Now, I can't quite say the same thing about the other side, but these are the common charges of the anions. We will learn other things, but in Chapter 2, we'd like you to master these facts. The other thing to point out is the aluminum cation. It never has a different charge. It is an S2P1, and when it loses those electrons to form a cation, it gets the noble gas configuration, which is group 8A. A lot to grasp if you haven't had this since your second year of high school. So again, I do understand, but take some time and learn what they are. So, finishing this section off, these are, for our course, the must-know cations. You notice the +1s are found in group 1 of the periodic table. The +2s are found in group 2. But what's going to also happen is you may see some transition metals. We don't talk about them a lot in this course because they have varying oxidation states. Some of them have up to 6. But again, we want you to get a handle on them. The thing I put on the side is if there are 2 ions of the same element, and I have a nice example to follow, we need to use Roman numerals to designate it. If I have an iron +2 cation, I'll use a Roman numeral 2. If I have an iron +3 cation, I'll use a Roman numeral 3. And this is really how I'm going to go 2 slides up. Oh, it's not here. Well, we'll see it in the Zoom lecture. Okay, that's the best way to put it. There are the must-know anions. And again, -1, can't get away from them. -2, -3. And then there are the more complicated ones that we'll get into as we get deeper into this course. But you have to know what is their formula, and you have to know what their name is. The charge is on the total group of the ions. So when you're going to say the word sulfate, here is the sulfate ion, you will see that it's an SO4, and that 2- refers to the charge on the entire anion. Same thing with the ammonium anion. That charge refers to the charge on the entire species. So what I have on my lecture Zoom is a hard-boiled egg where the iron sulfide that forms, it is an iron Roman numeral compound. I guess I'll entice you to come to the lecture Zoom so that you can actually see what it is I'm talking about. The questions from the midterm, they are found at the end of the next section. I broke this up into 2 just because I wanted to be able to speak slowly and explain what's in this section.